Okay, this is the Emerson motor, which has been in use since somewhere around 1991, maybe even in the late 80s. It's a 1/8 horsepower motor. So it's the current motor that Shopsmith's been using for at least the last 16 or 17 years. So again, most of these motors are new enough they don't need much work, but about 1 in 4 I'm finding need bearings. Or if a person has done a lot of woodworking, they might have a lot of dust inside the motor and need to clean it out thoroughly. And so that's why we're putting this motor last. It's the least likely to need work. 4 bolts again, holding the case together. A small access panel with a couple of short screws. Under that access panel is where you have some of your contacts for the pigtails. So remove that cover. Remove the 4 case screws. Kind of have to pry this back cover off. There's a couple of small indents where you can get your screwdriver to help pry it off. The Emersons are available in a 110 or a 220. Basically look about the same. Okay, this one has the retaining bracket at the front for the bearing. There's actually 2 little wing type clips holding the bearing, so you just have to loosen it just a little bit. Part of the start relays on the shaft itself, like it was on the Franklin. So you might want to blow with compressed air, blow out the relay springs, and just to help keep everything clean so it works better. Okay, one of the clips didn't quite release when I was turning, so I had to use a screwdriver to help it along. There we go. Now we can really check the bearings for roughness. These were loose and rough. That relay switch seems to work okay. Now we can get the other end of the case off so we can have access to both ends for cleaning all the dust out, checking our wires. Inside this back cover is the capacitor and the start relay. The relay rubs on a plastic disc on the shaft. One customer recently told me their plastic disc had been broken and they're looking for a replacement for that. Again, I like to clean everything very thoroughly while I'm at it. Here I'm cleaning so that I can mark my electrical wires. In this case, there's 3 wires that have to be disconnected. 2 underneath and 1 over. So I'm using my handy red marker to show myself where that wire came from. Just easier than keeping track of notes on my workbench. And as always, check your wiring. Make sure there's no cracks or gaps or burnt marks. Replace your wires or cover it with shrink tubing. But again, these motors are pretty new, so you're not likely to find any bad insulation on these. I don't think I have yet. I'm actually surprised some of them have needed bearings, because normally you don't see a motor needing bearings until it's maybe 25 years old, so I guess some of the bearings nowadays just aren't quite as good as some of the older ones were. Okay, and this is the switch that makes the contact for your start relay. It's a check to make sure it's working good, it's not clogged with dust. Check to see if there's any corrosion inside. So at this point we've put on new bearings, cleaned everything up. We have one of those spring washers that goes in place at this end. So I'm getting that in place before I push the bearing in. To do this work well, you'll need a bearing press and bearing separators, or have a friend or your company that has access to those, because you're definitely not going to be able to get bearings on and off by yourself without that sort of a tool. I use a 12-ton bearing press. They have presses with much higher capacity than that, but this one has worked fine for me. I've replaced hundreds of bearings. So now I have to get all those connections back together. This motor footage is greatly edited for time. You'll see much more detail in the GE 1 1/8 horsepower footage. So much of it is redundant, and I can only fit so much space on one of these DVDs, so I had to eliminate every single step for every single motor to make sure everything can fit. So be sure to watch the GE 1 1/8 horsepower for a lot more information on the general techniques. And this here shows you what's unique about the Emerson motors. If there's something that I left out of the video, any questions that I didn't answer, you can contact me through email, through my website, through eBay. Give me a call. If you want to do the work yourself and find it's too much, you can always send me the motor or send me the shaft and I can put the bearings on for you. I'm happy to help that way too. You know how intimidating motors can be. They were quite intimidating to me at first. I really didn't feel comfortable until I'd done 40 or 50 of them and had seen everything. Had seen all types, and I guess I've seen all problems. Once in a while I might still find something new, a new problem. But I've seen motors damaged in floods. I've seen motors that cook themselves, seized bearings. At this point I've seen everything, but something new probably will pop up someday. Okay, I'm checking to make sure my registration marks are pretty much in line so I can get these bolts threaded back through. The Emerson's pretty good to work with, since it has built-in threaded nuts on the other end. You just have to etch those little, or etch or punch those little marks ahead of time so you know when things are aligned right. That gets your feet aligned right for bolting back into your motor case, but more importantly it helps you get these bolts into their right position much quicker. Those marks also show somebody in the future that this motor has been worked on. I've only had one or two motors that had markings like this, so I could tell. Okay, no gaps in the case. So everything should be aligned good. Now we just have to reconnect this pigtail. Get it through the right little slot so that cover can close back over it. And once we're sealed up here, we can test the motor, make sure everything went back together right, that it starts on and off correctly. And after we've tested it, we can put the shiv back on and get it back in the headstock.